Hey, welcome to another part in this series. We've really gone over a lot so far. We've gone over LMI and how it distributes DLCs to the routers, how it also tells whether it's active or not. We've gone over inverse ARP, how it solves one of the problems of mapping distant end IP address to a local reachable DLC, and we saw how to statically assign that map. And in this part, and I believe we're on part 4, in this part, what we're going to step aside and talk about real quick is encapsulation type. So we know that IP packets are encapsulated with an IP header, TCP, UDP header on top of that, on the network level of the OSI model. There is an encapsulation type for the actual frame relay frame. Now, LMI type is just, and let me bring up the LMI information. So this is the LMI type, and the LMI type, whether it's Cisco, ANSI, or QN933A, is just the format of this DLC information. So this is LMI Cisco format, and LMI DANSI or Q933A would have a different format for this DLC information, the status of it, the numerical data of the DLC information. Now, when we talk about frame relay encapsulation type, and let's go to an inverse ARP packet. Here's our ARP resolution inverse request. And the frame relay encapsulation type is really the LAPF header, the DLC information, any additional fields that's required by that encapsulation type. And we have two encapsulation types. We have Cisco, and then we have the standards version, IETF. Right. So keep in mind that if you want to talk with a distant end router that's on the frame relay cloud and the frame relay switch, and it's a standards route, it's not a Cisco router, it's some other type router, whether it be Juniper or whatever type of vendor. They're not going to support the Cisco proprietary LMI type, and they're not going to support the Cisco proprietary encapsulation type, which is this LAPF header. It's a different format. So there's two things that would have to happen. You would have to A, configure the frame relay switch so that it will accept and respond to LMI type of either ANSI or Q933A. And also step 2 would be to configure any routers that communicate to that standards router with the encapsulation type, this LAPF header type of IETF. So, and I'm not going to go in too much detail of the many ways to set this encapsulation type, but I will just show you the interface type, and as we go along, as we discover new commands, I'll point out where this encapsulation type can be changed on interface level, on a per DLC or a per DLC level also. Why would you change an entire interface encapsulation type to IETF if only one particular DLC was going to that standards-based router? So we'll delve into that a little bit more once we get into the interface types in part 5. I know I was going to discuss that in part 4, but this one I'm just going to show you how to change that encapsulation type. Now, if we do this on a Cisco router, if we have one side that's configured for Cisco encapsulation type, that LAPF header type, and we have the distant end configured for IETF encapsulation type, Cisco will recognize both standards, so it will still work. You really need to have another standards-based router to see when it doesn't work. Cisco will recognize Cisco and IETF, so you can do this, but it'll still continue to work. So at the interface level, if we want to change the encapsulation type at an interface level, see what we have on our interface. It's really encapsulate. Remember, to enable frame relay, we did encapsulation frame relay. If you hit the question mark, you'll see there's IETF. So what does that mean? It means that Cisco encapsulation of that frame is default to Cisco, just like the LMI type. Uh, um, Actually, no, I lie. The LMI type will try to auto-sense which one of the three LMI types the frame relay switch is configured for. So the encapsulation frame relay type is the only one that defaults to Cisco when it's being used. And what you can do to change that at an interface level is to change the encapsulation type to IETF, which is standards based. And it'll change all DELCs on that interface, all DELCs that router knows about on that interface, to encapsulation type IETF. So I'm not going to get into a little bit, I'm going to get a little bit more in depth once we get into interface types and assigning DELCs to specific sub-interfaces and whatnot in the next part 5. So this was just a side conversation about encapsulation, how you just got to be mindful that a distant end router could be standards based, and you need to either enable your whole interface toward all DELCs with IETF encapsulation. But as we go along, I'll point out how you can specifically add a particular DELC if you only have one DELC going to that standards router. So we'll talk about that a little bit more.